Hello everyone, today we're going to review the power of exponents and some different rules for exponents. This should be nothing you're not familiar with, but you just need a reminder. So you probably want to write a few things down just to remember the different rules for exponents. So first, some vocabulary that you need to know. Exponential terms have a base, an exponent, and a coefficient. So in this case, when you have 4x to the 6th power, the coefficient is 4, the base is x, and the exponent would be the 6. So there's your base, there's your exponent, and there's your coefficient. Sometimes the coefficient is 1, in which case, of course, you wouldn't write it. Like that, x to the 6th. Alright, adding terms. You can only add or subtract terms when they have the same base and the same exponent. They have to have both the same base and the same exponent. So for example, 7a to the 3rd plus 3a to the 3rd, they have the same base, the same exponent, so therefore we can add them together, right? See the a and the 3 bouncing around there? In this case, we just add the coefficients, and your answer is 10a to the 3rd. When they're different, or when you have more than one exponent per term, like in this case, as long as they're the same, x to the 7th y squared and x to the 7th y squared, see how they're the same? Got that nice little blinking green going on there? We can still subtract them and get 9x to the 7th y squared. When terms do not have the same base and the same exponent, they can't be combined. So therefore, 3x to the 4th plus 2x squared, they are different. They cannot be combined. That is a big no-no. Right? They don't go together. So we leave them the way they are. Now, multiplying. Multiplying, you can multiply or divide terms if they have the same base. The exponents, however, can be different. So for example, x to the 4th times x to the 3rd is the same as x, written a whole bunch of times, 4 times, and x cubed, written 3 times, which is the same as x to the 7th. So the rule is when you're multiplying, you add the exponents. All right, so here's the rule. To multiply terms with the same base, you add the exponents. X to the 5th times x to the 10th would be x to the 15th. Y squared times y to the 7th is y to the 9th, and a to the 100th times a to the 50th would be a to the 150th. When terms do not have the same base, they cannot be multiplied. So for example, x to the 4th times y squared, we can't combine them because they're not the same, right? We have an x and we have a y, so therefore they do not, that's a big no-no, they do not go together. So you leave them the way they are. If your term has more than one variable, or a coefficient, we treat each piece separately. Remember, multiplication is commutative and associative. Remember that from our earlier chapters when we talked about those two rules. So for example, 2x to the 4th y to the 7th times 3x to the 9th y. Put those together, that's the equivalent to 2 times 3. Put the x's together, put the y's together, and you get 6x to the 13th times y to the 8th. Now, since dividing is the inverse of multiplying, how do we handle exponents in this case? Well, if you have x to the 4th divided by x to the 3rd, the rule is, if you think about it, you have x 4 times on top and x 3 times on bottom. So if you cancel out the terms that are on top and on bottom, notice my great disappearing act that's going on here. What are you left with? You're left with simply an x. So when dividing terms with the same base, we subtract the exponents. So if we have x to the 8th divided by x to the 3rd, we would subtract and get x to the 5th. M to the 10th divided by m to the 15th, we would subtract and we would get m to the negative 5. And in this case, 8, we would divide 8 divided by 2 is 4, subtract the a's, so that's a to the 3rd on top, subtract the b's, and you get b to the 3rd on bottom. Now, that brings us to exponents of exponents. When you have an exponent that's raised to a power, for example, this example, x to the 4th raised to the 3rd, the rule is, or this is equivalent to, x to the 4th 3 times. And we know from the previous slides that when you're multiplying, you add the exponents, which is equal to x to the 12th. So the rule for exponents of exponents is we multiply. We multiply the exponents together. We can distribute an exponent like this across multiplication or division. So for example, we have x squared y cubed raised to the 4th power. We distribute across, we get x squared to the 4th, y cubed to the 4th. which is then 2 times 4 is 8, 3 times 4 is 12. Right? So you can distribute across like that. You do the same thing for the coefficients. It becomes 2 to the third, a to the third, b to the 15th, which is 8, a to the third, b to the 15th. And we can even do it when it's division. So it becomes 9 squared, x to the 20th, y to the 14th, and z to the 2nd. So 81. You cannot, no way, not ever, no how, distribute an exponent across addition or subtraction. That is a big, big no-no. Do not do it. So for example, x plus y cubed is not the same as x cubed plus y cubed. You cannot do it, don't make that mistake. However, x plus y cubed is x plus y times x plus y times x plus y. You have to multiply it out, right? So you have to do that. 0 power. Now, what happens when something has a 0 as its exponent? Well, let's consider x to the m divided by x to the m. The previous rule we talked about was that you subtract. So if we subtract the exponents, we wind up getting x to the 0. But what do you have when you divide something by itself? Something divided by itself is always 1. Therefore, 1 has to equal x to the 0. So, something with an exponent of 0 always equals 1. 1,284,947 to the 0 power is 1. That big expression raised to the 0 power, it's 1. And xy to the 0 is, tricked you, it's not 1, it's x. Negative 5 to the 0, not 1, it's negative 1. Negative 5 in parentheses to the 0, that's 1. All right, negative exponents. Watch this pattern. 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 3rd is 8. Say along with me. 2 squared is 4. 2 to the 1st. What is going on here? What's happening? Well, it's getting smaller. Let's continue the pattern. 2 to the 1st, that's 2. 2 to the 0, that's 1. 2 to the negative 1, it's 1/2. 2 to the negative 2, it's 1/4. We are dividing by 2 each time. 2 to the negative 3, that's 1/8. So notice that 2 to the negative 1 is equal to 1/2, which is 1 over 2 to the 1. 1/4 is 1 over 2 squared. 1/8 is 1 over 2 cubed. So that leads us to a rule. A negative exponent drops the base and the power to the denominator. So b to the negative x is 1 over b to the x. Right? It drops them both to the denominator. Or if the negative number is in the denominator, then it raises the base up. 1 over b to the negative 1, negative x. All right, it's going to cause it to flip up, and you wind up getting b to the x. So 3 to the negative 3 would be 1 over 3 cubed, which is 1 over 27. 1 over 2 to the negative 4 would come up, so it would be 2 to the 4th, which is 16. X to the 4th, x to the negative 2 would be x to the 4th times 1 over x squared, and your answer would wind up being x squared. And in this case, the x to the negative 1 would come on top, so we'd have x to the 8th on top. Negative 10 minus negative 3 is negative 7, so we'd have y to the 7th on bottom. So the answer would be x to the 8th over y to the 7th. In this case, we would distribute across the negative 2, so we would get a to the negative 4, which means it would be on bottom, a to the 4th on bottom. B to the positive 2, so it would stay where it is. 3 to the negative 2, so it's going to come up on top, which is going to make it a 9 on top. C to the 10th, so it would stay where it is. Now we get to fractional exponents. So think about this. X squared, squared to the 1/2. Since 2 times 1/2 is 1, that means this is equal to x to the 1st, or x. All right, so see that rule. Usually, if we square something, how can we get back to the original value? Well, we do the opposite. It's the same as a root. So 1/5 would be the same as the x goes over there, the 5 goes around in a circle, and here it comes, there it lands. It's the fifth power, fifth root. So it's the same as a root. When you have x raised to the a over b, the x is going to swing over there and go underneath here. It's bouncing all around and settle down. There it is. And what happens to the b? It swings all around, swinging, 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 and where's it going to be? It's going to wind up right there. And then the a number in the numerator, remains a power. So the a, here it comes, and it settles in right there next to the x. So, x raised to the a over b is equal to the bth root of x to the a. 4 to the 3/2 would be the square root of 4 cubed, which is 8. It's a big 8. Alright, so simplify this one. Well, it would be the third root of 125, which is 5, and then 5 squared is 25. What about 81 to the 5/4? Well, the 1/4 root of 81 is 3. 3 to the 5th is 243. 36 to the, well, this one's a little easier. Think about this. This is 6 divided by 2, so it's 36 to the 3rd power. So you would raise 36 to the 3rd power, and you get a really big number. I don't know what it was. All right, so fractional exponents, when you have two fractional exponents, we can add them together. So you would add 6/7 plus 23/14. And you would get 12/14, so you get 35/14. For the middle one, you would subtract. So 2 minus 1/2 would be 3/2. 2/5 minus a negative 2/5 would be 4/5. And you would distribute 5/9 times 3/2, which would be 15/18, b to the negative 3, and c to the 1/2.